Right, let's go and look at the topics that come up in the first half of Higher Test 2. Solving equations. Here you go. Let me just check that this hasn't got a... Looks like it'll probably have a whole number solution. So let's change that to minus 7. Okay. Now, being a calculator paper, all we have to do is change this. But remember that... Sorry, let's just do that. That you should put... I'm making a lot of mistakes here. I'm just thinking about a million and one other things that are going on in the world at the moment. Sorry. And c is equal to minus 7. Put the negative numbers in the bracket. Write out the formula. X equals minus b plus or minus square root of b squared. Take away 4ac all over 2a. And once you've done that, all we're going to do is we're going to replace b with minus 5, a with 3, and c with minus 7. So let's do that now. Now this one's critical. The b squared one is the critical one that you have to have brackets in. Okay. Right, let's try that. And then times 3 times minus 7 all over 2 times 3 is 6. I think I can do that. And get your calculator out, and you should have it. Okay, let's check. So it's a big fraction, then it's minus 5 plus the square root of minus 5 all squared. Take away 4 times 3 times brackets minus 7, close brackets, all over 6 equals. And then I think in the question paper you have to give it to 2 decimal points. So here you go, 2.57. Now I'm going to get rid of everything else. Do I make the 7 one bigger? No, I crossed out. I got rid of a 3 first. So it's 2.57. And then if we go back, just going to find the second root. The roots are the values of x, in case you're wondering. And there you go, press the S to D, minus 0.90, I'm going to get rid of everything else. That 0 is going to go up to 1 because I first got rid of a 6, so it's minus 0.91. Okay, there you go. Let's look at another equation where the calculator isn't so handy and it's your algebra skills that you need. Here we go, 4x minus 3 equals x over 5. And the fly in the ointment is this 5 here. So what I'm going to do is I'm going to multiply the whole equation, that is every single term, by 5. Let's work from the right. And you'll see why I multiply by 5. X times 5, then divided by 5, it goes back to being good old x. And then I multiply every term on the left here by 5, and you get 20x minus 15 equals x. We've got x's on both sides. We get all the x's on one side, numbers go to the other, and what do we get? We get 20x, take away x, equals 15. Remember the change signs. 20x take away x is 19x, and then x is 15 over 19. Then check. You leave it as a fraction. Does it specify? If it doesn't specify, then just leave it as a fraction. Okay. Right. Let's remind myself now what my other topics were going to be. Accuracy of measurements. Now this is an interesting one. Here you go. Let's say Ben has a measuring cup of 50 milliliters, correct, to nearest 10 milliliters. He wants to fill a container of 2 liters. Notice the difference in units, capacity. Correct to nearest liter. You see, that's quite a big range of error. What's the maximum number of uses of the cup to fill the container? First things first, let's pick up some method marks and see what are the error bounds for these measurements. So here we go, let's deal with the measuring cup first. So if I put cup here, and it's correct to the nearest 10 mil. So it could be 50 mils, or it could be 60, or it could be 40. So what's the lower bound and the upper bound? Well, it's halfway between 40 and 50. Add those two together, 40 and 50 is 90, halve it. Here's your lower bound, it's 45. What about the upper bound? Well, you add 50 and 60, 110, then divide it by 2. So the upper bound is 55. We'll come back to that. Now, what about the container? Well, the container is measured to the nearest litre. We'll come back to the change in units in a moment. So it can either be 2 litres, or 3 litres, or 1 litre. So what's the lower bound? It would be 1.5. How did I get that? I added 1 and 2, and then halved it, 1.5 or 1.5. What about the upper bound? 2 and 3 is 5, divided by 2, 2.5. So, actually, just so we don't forget about the units, let's write millilitres here, and that fancy L for litres here. Okay, so the cup could be as small as 45, or just under 55. The container could be as small as 1.5 litres or as big as 2.5. Now let's look at the question. What's the maximum number of uses of the cup you will have to make to fill the container? Well, obviously, it's going to, if the container's at its maximum, that's going to increase the number of uses of the cup. So we're going to assume that the container is 2.5 litres. But do I use 55 millilitres, or do I use the capacity, the lowest value of the cup, 45? Well, I'm trying to find the maximum number of uses of the cup. So if the cup's got the smallest amount, I'd have to keep filling it up more than if it had the largest. So I'm going to assume that the cup's at its worst, at its lowest capacity, 45 millilitres, and that the container is at its maximum capacity, 2.5 litres. Now, a litre is 1,000 millilitres. So we're now going to change the larger units into the smaller ones. So my container could be as big as, or just under, 2,500 millilitres, and my cup could be as small as 45 millilitres. How many times would I have to use my cup? So that's a division question, isn't it? So do 2,500 divided by 45 equals almost definitely a decimal, 55.5, and you would round it up, because if you put just 55 cups worth in, it would be just under. So you would need 56 cups to fill it, okay? Right, now, the last one we're going to look at is transformation of graphs. Nice and straightforward, okay? Here we go. Here's the graph of a function. Whoops, let's see if I can get that bit better. And it's the graph of y equals x squared. On this graph, sketch the graph of y equals x squared. So it's the same thing, minus 4. Right, now, it's good when you just have a number added or subtracted to your function. Now, by function, I mean, that was the original. Here it is again, but then we've got minus 4 now added to it, or added to it, yeah, in the sense of it's being added onto it. So, whenever a number is added or subtracted to your original function, then it moves it vertically. That's up and down. And if it's positive, it moves up, negative, down. It's intuitive, okay? So I've got minus 4. That means I would move it up minus 4. Only mathematicians could use that language. In other words, I'll move it down 4. So I'm going to sketch the graph. It's only a sketch. And then to make it clear to the examiner that I knew what I was doing, I put the coordinates of where it crosses the y-axis. Okay? There was no other information given, and I don't have to, with the sketch, work out where it crosses the x-axis. I don't have to find these points here. Okay? Right. That'll do. Thank you.